Okay guys, so this is going to try to get us to wrap up section 2.1. Very big section in our lives for finding derivatives. Huge, huge. We got to get it. Okay, it's going to probably take us a couple days. Okay, and that's okay. And that's okay. Doing the derivatives the long way. You'll be much happier in 2.2. Much happier. Okay, but I don't know what you're going to have in college. I don't know what they're going to tell you, what's going to be acceptable. So we got to be ready for everything. And we will be. And we will be. So, here's three situations where there's no derivative, okay? Where the derivative does not exist. One, if at a point the tangent line is a vertical line, okay? So if you find the equation of the line or equation of a tangent line and it's a vertical line, the derivative does not exist there. This is an example. Y equals x to the 1/3. We're not going to do these until section 2.2, actually finding the derivatives, okay? A graph with a sharp turn. I copied the same thing. A graph with a sharp turn. Example, absolute value. If you have an absolute value graph, that's considered a sharp turn. There is no derivative there at that point. You might be able to find one here. You might be able to find one here, but at that point, no derivative. And a graph that's not continuous. Okay, if it's not continuous, there's no derivative at that point either. Okay, so these are three situations where there's no derivative. So we're going to finish this section with finding the equation of a tangent line. Okay, and these are the steps that you have to go through. Number one, you find the derivative of your function. Okay. Number two, you find the slope, which means after you find the derivative, you plug in the point. Okay, and we'll talk about that. And then three, find the equation. So let's say that we had f of x was equal to x cubed. And let's say that they told us ahead of time, or we figured out the derivative was 3x squared. So we're going to save a little time finding the derivative. And they want to find the equation of the tangent line of f of x equals x cubed at, we'll say, 1, 1. Okay? So we find the derivative. Okay, well we got that. My derivative is 3x squared. Find the slope. Remember, the derivative is a formula. It's a formula for the slope. When you have a curve, your derivative is going to be different. Okay? Or the slope, I should say derivative. The slope is different at different places of your curve. Okay? So we want to find the value of the slope. Well, we take our 3x squared, and it tells me that my x is 1. I plug that in. So it's going to be 3 times 1 squared, which is going to be 3. There's my slope. So my slope is 3. My point is 1, 1. I plug that in. Y equals mx plus b. My y is 1. My slope is 3. My x is 1 plus b. b plus 3 equals 1. Minus 3 minus 3. Looks like b is a negative 2. So your equation is going to be y equals 3x minus 2. Okay, that is how you do it. Okay. So let me give you guys one to look at like that. And again, I'm going to give you the derivative, okay? I'm going to give you the derivative. We found a lot of derivatives. And we'll be finding more. But I'm going to give you the derivative. Find an equation of the tangent line through 2, 4 on f of x equals x squared. Okay? So, again, actually I do have one more thing after this too. Ugh. All right, so again, I'm going to tell you what the derivative is. The derivative for this one was 2x. We found it before. So you want to find we found the derivative, that's step 1. Step 2, we want to find the value of the slope. Take your x value and plug it in. 2 times 2 is 4, so that's equal to m. Find my equation, so if m equals 4, and the point is 2, 4, that's an x, that's a y. 4 equals 2 times 4 plus b. 4 equals 8 plus b. Minus 8 minus 8. Looks like b is a negative 4. So we are going to say y equals 4x minus 4. And there is the equation. Okay, hope you guys got that. Hope you got it. Hope you paused the video. All right, trying to get this last part in before my free block is over. What do I do with it? It's right here. So, it says, use the alternate form of the derivative to find the derivative at x equals c if it exists. Here's your alternate form of the derivative. The limit as x approaches c, f of x minus f of c over x minus c. And my function is x squared minus 6x plus 5, and c equals 1. Okay? So, let's plug into the formula. The limit as x approaches c, well, x approaches 1. F of x, well, what's f of x? X squared minus 6x plus 5 minus f of 1. Okay, my c is 1, I gotta plug 1 in here. When I plug 1 in here, I get 1 squared minus 6 times 1 plus 5. 1 minus 6 plus 5. 1 minus 6 is negative 5 plus 5 is 0. And that's all over x minus c, x minus 1. So I want to see if I can factor that. So I've got the limit as x approaches 1. X minus 5, x minus 1, over x minus 1, those cancel. Now you can plug your 1 in. When you plug in a 1, we get negative 4. Okay? So if I wanted to find a tangent line for that, okay, that's the value of my slope, my value of negative 4. Now it says when c equals 1, which means when x equals 1. So if I want to find out what my y value is for that, I plug this into my function, okay? 1 squared minus 6 times 5 plus 1 right here, okay? When I do that, I get y equals 0, so that's my point, 1, 0. My slope is negative 4. So I'm going to say 0 equals negative 4 times 1 plus b. 0 equals negative 4 plus b. Add 4, add 4. b is 4. So now I get y equals negative 4x plus 4 as my equation of the tangent. All right, guys, I hope that made sense. If not, ask me questions in class or send me an email.